One more little plane calculation to do here. Find the angle between two planes. So if these two, my two hands here are two planes, there's some angle between them. You know, this looks like a little bit bigger than, this maybe like a 60-degree angle or something like that here. How can we, you know, here are the equation of planes. How can we use the information about these two planes here to get the angle between them? And the little trick that is important here is realizing it's find the angle between the normal vectors of our planes. So what we have to do here, find the normal vectors of the two planes and then find the angle between those normal vectors. The two normal vectors, it's very easy to write down. First normal vector, all we have to do is read off the entries here. 2, 3, 7, read off the entries of the coefficients of x, y, and z. And ditto for our second normal vector, so 4, -2, and 2. So how do we find the angle between these two vectors? We can do it with either dot product or cross product. We have two ways to do that. We've talked about those in the previous couple of sections here. Let's do dot product calculation. So for this, we would need n1 dot product n2. So that would be 8 minus 6 plus 14. And that looks like 16 to me. And we also need the magnitude of each one of these. So the square root of 4 plus 9 plus 49. So that looks like square root of 62. And the magnitude of the second one is going to be square root of 16 plus 4 plus 4 is square root of 24. So what is our answer? Our formula tells us that cosine of theta, that theta being the angle between our vectors, is going to be the dot product of those vectors divided by their respective lengths. And so theta is simply the inverse cosine. So I don't think this simplifies particularly nicely, so I'm just going to leave it in this form. So yeah, finding the angle between the planes is just a question about finding the angle between the normal vectors, and angle between normal vectors, that's information. We can read off the normal vectors. It's good practice from these equations, and good little practice from the dot product section.